Hi there.
What the hell? Where did you come from? What's going on here in the system?
I came from the back door. I found myself all of a sudden here in your system. So just for a while, please, could you stop using the mouse? I got you finished. Hey, what's that?
What? Seriously? Again? Another one? Guys, where did you come from? How come they are here in our system right now?
I finally find myself here. I was in the window pocket for quite a very long time. It was very hot back there, and it's finally cold here. Can I have some fun? And please, just be patient. Don't switch off your engineering station. Just for a while. Thank you.
Immediately stop the remote session and just contact the supplier. They will need time to reach us now. We don't have anyone from cybersecurity to support us. Just do it quickly.
Hi everyone, welcome to my YouTube channel, ICS and Cybersecurity. What is engineering workstation and what is the purpose of engineering workstation? And why engineering workstation play a major role in any OT ICS environment? Why do we consider it a critical component? And from security risk perspective, why engineering workstation could become a major threat source to the different components and devices used in ICS environment. All these points I will cover it in this video today. I hope you find it informative, and if you know anyone who can make benefit of this information, you can learn from it, please share it. In any industrial control system environment, we are dealing with multiple processes. Now, all these processes are managed and controlled via the connected industrial control system devices, and these devices could be a DCS, a distribution control system, a safety instrumentation system. It could be a programmable logic controller, industrial switch. It could be a remote I/O card like what we have here, Profinet and Modbus remote I/O card. These devices, different components could come also from multiple vendors, multiple suppliers, and all these suppliers system are managed and configured using a single or multiple engineering workstation. In some cases, we have what's so-called a maintenance laptop, and this maintenance laptop is also used for the same purpose, but it could be also used for a specific one or two components. The advantage of engineering workstation is you have a central access point where you can manage all these PLCs and remote I/O. You can configure it, you can do all the diagnostic you need via the software and application provided by the supplier and vendor. Sometimes you have open source software. So engineering workstation play a major role in any industrial control system environment, especially in configuring, maintaining, troubleshooting, and diagnostic of the connected industrial control system components. And considering industrial control system environment as a static environment, because we don't have that much of changes to the, for example, to the program we are running in the programmable logic controllers. We don't have much of changes within the process. You could only have a change from time to time in filling oil, for example, and in water filling process. Maybe from time to time you change the water bottles shape or the oil bottles shape. Therefore you need to make some improvement or update. So that's why we call it a static environment. Therefore you will not need the engineering workstation like 24/7 days like what we have with the human machine interface. So there is a limitation how often we will need the engineering workstation, and most of the cases we will need it to troubleshoot if there is any failure within any certain component. This is basically the major functionality of engineering workstation and why do we need it. Now let's take it to the next part where we talk about the risk and the threat source we could get from the engineering workstation. Now, if you are connecting your engineering workstation to multiple components, it means, and these components are coming from multiple suppliers, it means that you are using multiple software applications to configure and maintain these and calibrate these components, which means you are having additional risk when it comes to cybersecurity. And you really need to consider this when you assess any engineering workstation. If hacker can maintain access to your industrial control system facilities via engineering workstation, then we are talking here about a major risk. The attacker could use all the available tools, software, and application against your industrial control system. And one of the very common tools used in industrial control system, the scanning tool in engineering workstation. Now, the scanning tool, it's really important for troubleshooting, for maintenance people, for vendors doing troubleshooting. Let's assume we have one of the programmable logic controllers or one of the switch disappear from our network, for example, and we need to troubleshoot that. So it's one way to do it. Now, or we are adding the spare part, let's assume a network switch or a new PLC, and we need to configure the IP address for that PLC. Then we use this kind of scanning tools. As I said, it could be from the vendor or it could be an open source device. Now, from functionality perspective, it's really important. We really need such a tool because that makes our life easy. So in my case here, for example, I have discovered when I run the scan, and it didn't take a lot of time. In this case, the attacker does not need to run his or her own tools. They can use this tool against your industrial control system. And what we see here, I was able to detect the remote Profinet IO device, and I can easily go and change the IP address for this device, and it will not communicate, which means it will not work. In my case, this remote IO device, I'm using it for the Lightning Tower, which is used for safety purpose, and that could have safety impact as well for the operator behind the product line. I take it to another level where I have a 7-1200 and a 7-1500. I also have the scalance switch and the Cinematic HMI touch panel I'm running back there in my lab. Now, if you look at it, for example, if I take the scalance switch here and the attacker were able to manipulate the IP address, it means, let's just assume he changed the IP address and that's all. What will happen here, this is a core switch in my lab setup, which means it connect my S7 1200 with my S7 1500 with certain functionality being configured already, and the attacker will be able to disconnect this communication. Nothing will communicate anymore, which means the synchronization between my index line product, when it's finished, it will not be picked up by the robotics arm, and that will delay the packaging process. So this is really important, and this is just a simple tool used in industrial control system facility, and you can imagine how the attacker can misuse your system by manipulating a single switch within your industrial network. Another thing here, as I mentioned, for example, I'm running the IO, remote IO devices. So I have the Modbus, for example, so I have to configure it and maintain it from another tool provided by the same vendor. If I take it to TIA portal, where I'm running and managing all these devices, if I go to the PLC, for example, here, if the attacker have access to your TIA portal and you don't have a proper security around it and within the same application, then the attacker can go and change the logic of your PLC. He can change the logic of certain components and cause severe damage to your environment. He could cause a safety related issue inside the industrial environment. For example, if we are also using a safety instrumental system. Now, I'm not evaluating any product here from security perspective. I'm just talking about how attacker can make use of such application. And if we come to TIA portal, we have multiple features, security features could be enabled to secure against such thing up to some level. Now let's take this example for my PLC S7 1500, which is connected to a robotic arm simulation kit. So in this line, what I have here is the push button where I can move the robotic arm to the right position, and to some point the limit switch or the safety switch will stop the robotic arm at certain level. If the attacker is able to access to my logic and manipulate it and disable this functionality, the robotic arms will continue moving to the right side, which will cause a physical damage, and it could also cause a safety issue within my industrial environment. So this is one example for what could happen if attacker can reach to your industrial control system engineering station and manipulate the logic within that engineering workstation. Remember, even if you have a network traffic monitoring solution within your engineering station, and the attacker easily can start that application and see what traffic are running within your network, he can determine, okay, what are the weakest or vulnerable communication protocols you have in your environment, and he or she can use that to their advantage. So you always need to be aware what is running in your engineering workstation and how you protect that, whether with a basic security control or if you need to consider an advanced security control to make sure your environment is properly secure. Now let's take a look at the robotics arm and how the limit switch, or as I call it, the safety switch in my case, stop the movement of the robotic arms to the right and protect the robotics arm from any physical damage, and protect the operator in the area, because at some point the robotic arm could hit the operator and cause a safety or a personal death. So let's take an example here. Right now I'm moving the robotic arm to the right, and the robotic arm stopped at this point. And if I stop the functionality of the limit switch, or if the attacker is able to manipulate this function and disable it, the robotic arm will continue moving, pushing the limit switch, and cause a damage to that robotic arm. It wasn't designed to to work this way. Therefore, we need a safety switch to protect our device and to protect the human being, for example, the operator around the area. So this is a very quick example on how the attacker can manipulate the process via using the engineering workstation. As a conclusion of today's video, engineering workstation is really critical device in any industrial control system environment, from both functionality perspective and from security perspective. While assessing industrial control system engineering station or a maintenance laptop, which is at some point doing similar functionality, you need to be aware about what are the applications, what are the software running inside these environment, and at the same time you need to consider how attacker can use these softwares, these applications against the environment, and what are the security control we need to provide to limit the risk at least to some point. Now, remember, engineering workstation in some environment required an update connecting to the internet from time to time, to connect to the vendor server, to update certain drivers, for example. From time to time, like during COVID, you will need to maintain a remote access and grant access to the vendor from another country, for example. And this is in itself is a major risk, and we had several incidents where attackers were able to maintain access to the facility and cause damage to that facility. I really hope you find this video informative and help build good awareness around engineering workstation and other major components within any industrial control system environment. If you find it again helpful for you, if it can build awareness around the OT ICS Society, please share it with others. I will be really grateful, and see you in another video. Bye.